Good day, engineers. Today, we will be discussing about the concepts of the analysis of T-beams. So this is for the course Reinforced Concrete Design. Let's start. So we will start our discussion by let's start interpreting the code indicated in NSCP 2015. So nandito sa gilid yung table natin. So let's start with the flange location na each side of web. So, to interpret this one, kakailanganin natin ng floor plan. So, if we have a floor plan, let's say, kunin natin yung section nung gitnang beam, which is ito. So, pag kinuha natin yung section niyan, kunin natin yung cross-section niya at midspan. So, let's say, this will be section AA. So, from section AA, so, kung mapapansin natin, at the left side, it will support a slab, and at the right side, it will also support a slab. So, ibig sabihin, our resulting figure for section AA will be this one. So, this will be section AA. So, that will be for section AA na figure natin. So, mapapansin nyo, meron siyang B sub F. So, B sub F is B sub F is the effective flange width. Then, meron siyang H, which is the total height of the beam. Then, meron tayo dong B sub W, which is the base of the beam or yung sinasabi natin na base of wave. Then, nandyan din si H sub W. So, that is H sub W, which is the height of web. Then, meron din tayong small letter h or yung sinasabing nating T sub S, which is the thickness of slab. Then, the last one is yung OHFW. OHFW is the overhanging flange width. So, yun ngayon yung magiging parts nung T-beams natin. So, lahat naman to, yung H, yung BW, yung HRTS will be given dun sa problem. Ang kailangan nating hanapin kapag given yung floor plan natin is yung effective flange width. So, makukuha natin yung effective flange width using the table indicated in the NSCP 2015 provision. So, yung unang sabi dun, barayin lang natin to. Yung unang sabi doon is kakailanganin natin si 8H. So, sabi kasi each side of the web and naka-indicate sa table that the effective overhanging flange width beyond face of the web. So, ibig sabihin, since ito si OHFW, kung mapapansin natin sa T-beam, there are two sides of the web. Meron din dito, then meron dito sa kabila. So, ibig sabihin, para makuha natin si B sub F, kailangan natin i-add si B sub W sa dalawang OHFW or overhanging flange width. So, ibig sabihin nun, kapag i-interpret na natin yung code na nasa table, all values should be multiplied by 2. So, that means we will have B sub W plus 2 times 8H. So, this will be B sub W plus 16H. Then, the second requirement of the code is such that B sub F should be equal to B sub W plus dalawang SW over 2. So that means this will be equal to BW plus SW. Then the last requirement will be ln over 8. So that is B sub F is equal to B sub W plus 2 times ln over 8. So, ito magiging 1, then this will be 4. So, that means this will be B sub W plus ln over 4. Yan ngayon yung requirements ng code for a T-beam or a flange location of each side of the web. So, ang next nating i-interpret, what is H, what is SW, and what is L sub N. So ngayon, let's interpret what is H and what will be SW and what is LN. So, dun sa H, siya yung sinasabi natin na thickness of the slab or siya si T sub S. So, that is thickness of slab. So, ngayon, pwede natin siyang i-interpret na diretso as B sub F will be equivalent to B sub W plus 16H. So, automatically, substitute lang natin dito yung thickness of the slab. So, the next to be interpreted will be S sub W. Ngayon, interpret natin si S sub W using, again, the floor plan. So, may interpret natin si S sub W kapag kinuha natin tong cross-section na to. So, cut natin dito. This will be section B, B. So, pag kinat natin yung cross-section na yan, lalabas yung ganitong figure. So, ang hinahanap kasi sa atin, sabi ni code, S sub W is the clear distance to the next web. So, kung ito yung beam na i-analyze natin and it will give you a figure of a T-beam. So, kakailanganin natin hanapin kung anong clear distance niya dun sa next web. So, kung ito yung figure na lalabas pag kinat natin siya on a section BB, take this as section B-B. So, ibig sabihin, kapag ito yung beam din, or ito yung beam na ina-analyze dito, which is ito, so, ang clear distance to the next web will be ito. Since dalawang side yan, so from here, meron ka nito, then from here, meron ka dito. Which is indicated sa ilalim as SW sub 1 and SW sub 2. So, syempre nga naman, kapag naggagawa tayo ng floor plan, laging ang given distance is center to center of supports. So, kaya meron ka dong L sub 1 tsaka L sub 2 sa ilalim. So, ibig sabihin, para makuha natin yung clear distance to the next web, let's say, yung width nito will be BW sub 1. Then, yung width nito will be BW sub 2. And yung width nito will be BW sub 3. So, para makuha natin yung clear distance to next web, dapat is SW sub 1 will be equivalent to L1 minus SW or BW, that will be BW sub 1 divided by 2 kasi kukunin natin yung kalahati o babawasan natin to ng kalahati, then babawasan natin ng kalahati yung kabila. So that will be minus BW sub 2 divided by 2. Then for SW sub 2, that will be L sub 2 minus BW sub 2 over 2 minus BW sub 3 over 2. Yan ngayon yung clear distance natin to the next web. So, kung i-interpret natin yung code, may chances na si L sub 1 hindi siya equal kay L sub 2. Or kung ang mangyari, equal si L sub 1 kay L sub 2, pero yung width nito is hindi equal sa width nito. So, there are chances na hindi mag-equal si SW sub 1 and SW sub 2. So, if yung SW sub 1 is not equal to SW sub 2, ibig sabihin, ang interpretation ng code will be B sub F now will be equivalent to B sub W plus, hindi natin pwedeng basta-basta ita times 2. So, that will just be SW sub 1 divided by 2 plus SW sub 2 divided by 2. Kasi clear distance sila to the next web and hindi sila equal. So, valid lang yung interpretation ng code if meron pang isang condition, SW sub 1 is equal to SW sub 2. So, ibig sabihin, ang B sub F natin for this condition is equal to BW plus SW divided by 2. Kasi nga, equal yung dalawang clear distance to the next web. So, next to be interpreted is what is LN. So, yung LN natin, para kasi nating kinuha yung span nung mismong beam na ina-analyze natin. So, kung dito, ina-analyze natin tong beam na to, para natin siyang titignan dito sa side na to. So, para mo siyang titignan dito. So, ang makikita natin, yung beam na yon supported siya by columns sa side. So, kung supported siya by columns on side, syempre, sa floor plan nga naman, center to center distance pa rin yung ibibigay niya sa'yo from support. So, si L sub N will be the clear span length. So, clear yung span length niya, which is ito. So, indicated din naman sa drawing, ito. So, since clear yung kailangan mo, kailangan natin ibawas yung sides ng support. So, let's say, kung column yan, this is C sub 1, then this is C sub 2. So, ibig sabihin, para makuha natin si L sub N, that will be L is equal to, or LN, kasi yung hahanapin natin. So, L sub N is equal to L minus C1 divided by 2 minus C2 divided by 2. Ngayon, magiging valid na yung equation, which is B sub F is equal to B sub W plus Ln over 4 kasi tinimes 2 na natin siya. Ngayon, pag nakuha natin tong tatlong B sub F, pipili tayo whichever is lesser or least of the three. Yun ngayon yung interpretation of the code for each side of the web na flange location. So dako naman tayo dun sa next flange location. So, dun tayo sa one side of web. So, kunin ulit natin yung floor plan. So, para ma-interpret yung one side of the web, ang ibig sabihin kasi nun, let's cut this one into this one. So, ibig sabihin, or cut natin yan na ito lang. So, this will be CC. Ito, pares lang din yan pag ito yung kinat mo. So, pares lang din pag ito yung ikinat. Then, cut din natin to. So, kakat mo din to. Then, ito rin. So, ibig sabihin, nasa perimeter siya. Kung mapapansin nyo, ang common nila is, lagi silang may supportang slab on one side. Unlike nung gitnang beam, nakasupport siya ng slab on two sides. So, kapag kinat natin yan, ang lalabas na figure will be this one. So, this is section CC. So, yan ngayon yung interpretation nung one side of web. So, para siyang inverted na L-beam. So, nandun pa rin si H, which is the total height of the beam. Si B sub W, which is the base of the web. Then, si H sub W, which is the height of the web. Si H or T sub S, which is the thickness of the slab. Si OHFW, which is the effective overhanging flange width. And si B sub F, which is the effective flange width. So, syempre, we interpret the code. So, sa 6H, diretso lang yan. So, that means that will be B sub F is just equal to BW plus 6H. Kasi i-multiply mo lang siya ng 1 kasi nga, one side lang siya ng web. So, ito lang siya. So, that means that is all multiplied by 1. So, yung sinunod na code will be B sub F is equal to SW over 2. Or BW plus SW over 2. BW plus SW over 2. So, pag kinat kasi natin yung pag kinat natin dito yung next web or clear span to the next web, let's say this is section D. So, pag titignan natin yan, ito yung lalabas na figure. So, this is section DD. Or D-D. So, mapapansin natin, isa lang yung next side of the web. Which is ito, SW1, then L1. So, syempre, para makuha natin si L sub 1, kailangan ulit natin i-minus or si SW1, kailangan ulit natin minusan si L sub 1 nung mga support. So, let's say SW sub 1. So, kung ito is BW sub 1, ito is BW sub 2. So, that will be L sub 1 minus SW sub 1 over 2 or BW sub 1 over 2 minus BW sub 2 over 2. Yan ngayon yung para makuha natin yung clear span to the next web. So, pwede na ulit siyang i-direct na formula na SW over 2 lang. Ngayon, yung LN ulit, syempre, siya pa rin yung clear span length. So, kung ito yung beam na i-analyze natin, For example, ito yung beam na i-analyze natin. Supported pa rin siya by column. So, ibig sabihin, ibabawas pa rin natin yung tig-kalahati ng dalawang column na sumusuporta sa kanya. Since at times, ang floor plan, lagi siyang ang support is or laging ang distance na given sa floor plan is center to center of columns or supports. So, direct, si B sub F ulit is equal to BW. So, times 1 lang yan. So, that will be ln over 12. So, pipili lang tayo ng lesser of the 3 or the least of the 3. Then, yun na yung effective flange width. So, yun yung interpretation ng NSCP 2015 provision na code for T-beam geometry.
So let's proceed on the concrete area for analysis. So, yung concrete area na tinutukoy, siya yung compression area of the concrete. So, makukuha lang natin yun dun pa rin sa equilibrium equation na ginagamit natin for a singly reinforced beam. So, yun yung C is equal to T. So, but instead of using 0.85 F prime C AB, we'll just use 0.85 F prime C AC for the compression side. Then for the tension, we will just use ASFY, assuming that steels are yielding. So, yung AC natin dyan is area of the concrete for compression. So, para makuha natin yung concrete area for compression, that will be now equivalent to AC is equal to ASFY over 0.85 of F prime C. So, ito na ngayon yung concrete area natin for compression na magbabalidate dun sa T-beam analysis natin. So, meron kasing dalawang condition na pwedeng mag-fall yung T-beam analysis natin. So, the first condition is such that yung A natin is lesser than or equal dun sa thickness ni slab. Nangyayari lang yan kapag yung area ng concrete natin is lesser than or equal dun sa area ng flange natin. So, yung area ng flange natin will be equivalent to BF times the thickness of slab. Ito ngayon yung i-compare natin dun sa concrete area or concrete compression area na nakuha natin kanina or yung galing dito sa equation na to. So, kapag na-prove natin yun, we can proceed to analysis of rectangular. So, mapapansin nyo, that is a rectangular analysis. Ang pinagkaiba lang sa rectangle kasi, bilang yung ginagamit natin doon. Whereas dito, B sub F multiplied by A. So, ang compression side natin is 0.85 F prime C BF A. Yun ngayon yung gagamitin natin for this analysis. Then, the next condition will be this one. Ito nangyayari if AC is greater than the area of the flange. Therefore, yung A natin will be greater than the thickness of the slab. So, kakailanganin natin dito or we have now a T-beam analysis. So, kung mapapansin mo, para ulit siyang T-beam or irregular shape na siya. So, unlike rectangular, hindi natin pwedeng gamitin that C or the compression side is equal to A times B or A times BF. So, magkakaroon na siya ng irregularity and we will solve this one using the three methods na ipepresent ko. And yung most common na pinagkaiba nung dalawa is dito ang AC natin is equal to BF times A. Doon naman sa kabila, yung AC natin or yung area ng concrete natin will just be equal to A times BF plus BW times A minus TF, or simply the area of concrete for this one will be area of flange plus BW times A minus T sub S. So, yun ngayon yung significant na pinagkaiba nung dalawang conditions natin. Ngayon, magpo-proceed tayo kung paano natin i-analyze yung rectangular beam kapag na-prove natin na kailangan natin ng rectangular analysis. So, kung ito yung beam natin, so, let's say na-prove natin that A is lesser than or equal to the thickness of slab. Kasi syempre, si area ng concrete is lesser than or equal dun sa area ng flange. So, dito, kung meron tayong rebars dito sa tension side, which is AS, so, ibig sabihin, masusunod pa rin natin yung stress diagram niyan, which is ito, having a stress of 0.85 F prime C and a depth of compression block of A. The difference is that kung ito yung T natin, then dito yung C, ang difference niyan is C is equal to T. Kung nasanay tayo sa 0.85 F prime C AB, so dito, yung C natin magiging 0.85 F prime C A times B sub F is equal to AS Fy. Ngayon, yung theoretical value ni A is makukuha natin through the equation A is equal to AS Fy over 0.85 F prime C B sub F. Then, pag nakuha natin yung A theoretical, syempre, kukunin natin si C, which is A over the beta 1. Susundin pa rin natin yung equations ni code na pag ang beta 1 is lesser than or equal to 28 megapascal, we use a value of beta 1, or kapag ang F prime C pala natin is lesser than or equal to 28 megapascal, ang beta 1 natin is 0.85. Pero, if F prime C is greater than 28 megapascal, so we will use the equation indicated in the NSCP, which is beta 1 is equal to 0.85 minus 0.05 times F prime C minus 28 divided by 7. So, pag nakuha na natin yung A theoretical ulit and C theoretical, i-verify pa rin natin yan kung mag-yield yung steel or hindi through the equation Fs is equal to 600 times D minus C over C, which is yung D pa rin natin is mula dun sa compression down to the centroid of the reinforcement. So, kapag na-prove natin that steel yields, yung A theoretical na nakuha natin kanina is A actual and C theoretical is the C actual. Then, puproceed tayo in getting the net tensile strain. So, kapag ang net tensile strain natin is greater than 0.005, so that will be ductile, and we can conclude that the reduction factor is 0.9. But if the net tensile strain is lesser than 0.005, nandun ka sa transition zone or in between E sub Y, nandun ka sa transition zone. So that means kailangan natin i-derive yung equation of a line. So doon natin makukuha yung reduction factor using an equation of the line. Then, after that, pwede natin kunin si Mn, which is pwede natin kunin on the compression side or on the tension side. So, it's either 0.85 F prime C, yung A actual natin times B sub F now, times D minus A actual over 2. Tapos, pwede din natin kunin yung Mn through AS Fy kapag na-prove natin na steel yields Fy yan. So, that will be D minus A over 2. Pero pag hindi natin na-prove that that is Fy, so, kailangan natin gamitin that will be F sub S. Then, the ultimate moment capacity will be equivalent to phi Mn. So, yan ngayon yung scenario for the analysis of rectangular beam kapag ang depth of compression block is lesser than or equal dun sa thickness of the slab. So, syempre, we can now proceed on the analysis of T-beam mismo. Paano kung na-prove natin na yung A natin is greater than the thickness of slab or yung concrete compression area is greater than the area of the flange. So, I will be introducing 3 methods to solve this condition. So, let's say yung diagram natin na-prove natin na T-beam. So, yung diagram natin is pwede nating hatiin sa dalawang parts. So, hatiin natin dito. So, itong side na to, kunin natin din yung side sa ilalim. So, makakabuo tayo ng dalawang stress diagram which is shown. So, ito will be TS. Then, this will be A minus TF. So, kung ito yung compression natin, so this will be C sub 1. Then this will be T sub 1. So this will be C sub 2. Then this will be T sub 2. So ngayon, on our first diagram, so at first diagram natin, pwede natin sabihin na C1 is equal to T1 dyan. Then, that is 0.85 F prime C BETS or BFTS is equal to ASF FY. Sa second diagram natin, we will have C2 is equal to T2. So that will be 0.85 F prime C. So that is B sub W times A minus T sub F is equal to AS W F Y. So mapapansin natin, hindi natin pwedeng gamitin yung dalawang equilibrium equations na to kasi unknown si ASF and unknown si ASW dyan. So, much better if we will have or if we will combine the two equilibrium equation such that C1 plus C2 is equal to T1 plus T2. Then remember, this T1 plus T2 can be equivalent to T. So, ibig sabihin, pwede natin gamitin to as T. Kasi remember din, yung ASF dyan and ASW, pag inad natin, so AS is equal to ASF plus ASW. So, ibig sabihin, makakabuo tayo ng steel area nung beam natin. So, kasi this is a steel area for a flange section, then this is a steel area for the web section. So, ngayon, ang pwede natin gamitin equilibrium equation para makakuha ng value ng depth of compression block will be the total equilibrium equation which is C1 plus C2 is equal to T. So meaning that will be equivalent to 0.85 F prime C BFTS or BETS plus 0.85 F prime C BW A minus T sub S is equal to ASFY. Etong term na to, dalin natin sa kabilang side. May iwan tong term na to para makuha natin kasi si A. So, ibig sabihin that will be, so, magiging 0.85 F prime C BW A minus TS is equal to ASFY minus 0.85 F prime C BF T sub S. So, divide both sides by 0.85 F prime C BW. So, lalabas si A minus TS is equal to ASFY minus 0.85 F prime C BFTS divided by 0.85 F prime C BW. So, yung A natin lang ang matitira. So, that will just be A is equal to ASFY minus 0.85 F prime C BFTS divided by 0.85 F prime C BW plus TS. Ito ngayon yung equation na pwede nating gamitin. So, this is plus T sub S. Ito ngayon yung equation na pwede nating gamitin to get the depth of compression block coming from this method number 1. So, this will be method 1. Ngayon, paano naman natin makukuha yung nominal moment capacity ng beam na to gamit yung method 1? So, sabi ko nga, this is Mn. Equivalent yan sa Mn1 na first diagram and Mn2 na second diagram. Then, this is H. From this one to this one, this is H. And this is A minus H or A minus thickness of slab. So, para makuha natin yun, since meron tong C1, ito meron C2, and meron tong T1, and meron tong T2. The much better way to get the nominal moment capacity is to get it from the compression block. So, dun tayo sa first diagram. Sa first diagram, kailangan natin ng moment arm. The moment arm will be, since dun sa original diagram natin, meron tayong D, which is the effective depth. So, that is a distance from the extreme compression fiber to
the centroid of the reinforcement or the AS. So, ibig sabihin, this one is kung D yung mula dun sa dulo hanggang dito, and si C1 nag-aak sa gitna ni H, so that means magkakaroon tayo ng moment arm from this one, which is D minus H over 2. So that means we can say that the first nominal moment capacity of a T-beam will be equivalent to, that is a value, so dapat dun natin kunin sa compression dito. So that will be 0.85 F prime C. So that will be B sub F times H times D minus H divided by 2. Yan ngayon yung first nominal moment capacity of the beam based on the first stress diagram. Next one, paano natin kukunin yung second nominal moment capacity? So, the second nominal moment capacity will be coming from the second diagram. Then, ano ngayon yung moment arm? Yung moment arm natin is ito. Pero, lagi pa rin natin yung kukunin on the compression side, yung nominal moment capacity natin or second nominal moment capacity. Kasi wala naman tayong given na ASF and ASW. Kasi kailangan pa natin silang kunin kung gusto natin na gamitin sila. Since given naman lahat ng dimensions nito sa compression, so yun na yung gamitin natin. So, the moment arm for that one will be, since yun, galing ulit sa taas is D, dun sa pinakaibabaw, syempre nabawasan na natin siya ng TF. So, that means pwede nating sabihin yung moment arm dun is D. So, moment arm. So, ang moment arm dun will be equal to D minus H minus, syempre ito is A minus TF over 2. Kasi babawasan pa natin yung value. So, that will be A minus T sub F over 2. So, that will be equivalent to, or this is H na lang. Kasi para hindi malito, this will be H. So, that will be D minus H minus A minus H over 2. Or buo kasi yan. This is over 2. So, this is A over 2. So, negative, ito pala magiging positive. So, negative A over 2, tapos ito negative. It will be positive. So, negative H plus H over 2. Now, we have a moment arm of D minus A over 2 minus H over 2. Ito ngayon yung moment arm nung given natin, which is also equal to D minus A plus H divided by 2. Yan ngayon yung moment arm natin. So, to get the second nominal moment capacity of the beam, so that will be Mn2 is equal to 0.85 F prime C. So, that will be compression dun sa second diagram. So, that is based on BW times A minus H times D minus A plus H over 2. So, yan ngayon yung value natin ng second nominal moment. Siyempre, bago tayo mag-arrive dito sa mga values na to, kailangan muna natin i-prove kung tama ba yung assumptions natin that steels are yielding. Meaning, kasi yung una nating makukuha, tama ba? That is the A theoretical. So, kailangan natin i-prove that A theoretical is correct para maging A actual siya, as well as yung C theoretical is correct.
kailangan natin ma-prove that Fs is greater than Fy, meaning, or greater than or equal to Fy, meaning the steels are yielding. Same pa rin naman yung formula which comes from the strain diagram, that is Fs times 600 times D minus C over C. So, after that one, kailangan pa rin nating kunin yung net tensile strain. So, which is, that will be coming from 0.003 dt minus C over C. dt is the distance from the extreme compression fiber to the extreme tension reinforcement. So, pag dalawang layer yung reinforcement natin, syempre, siya yung first layer of reinforcement. So, kasi dito natin makukuha yung reduction factor, which is phi. Tapos, saka na natin makukuha yung Mn coming from Mn1 and Mn2. Ipag-add lang natin sila. So, that will be Mn1 plus Mn2. So, ang lalabas will be the value Mn. Then, makukuha natin si Mu, or the ultimate moment capacity of the beam, by multiplying the reduction factor times the nominal moment. So, that will be the first method for the analysis of T-beams. Next method, method number 2. So, ang pinagkaiba lang niya sa first method is yung putol nung T-beam natin. So, kung dun sa first method, ang ginawa is inihiwalay yung flange part dun sa web part. So, for this method, ang ginawa is kinuha yung part na beam talaga. Then, ang tinira for the second diagram is itong part na to and yung kabila. So, that will be the difference for method 1 and method 2. So, for this method, so, since this will be the nominal moment, then this will be the diagram for the first nominal moment, and this will be the diagram for the second nominal moment. So, to get the value of A coming from this method, so from C1, that will be C1 plus C2 is equal to T. So, from the first diagram, ang C1 natin dyan, so if this is the C1, then this will be T1, then this will be C2, and this will be T2. So, for C1, that will be 0.85. That is 0.85. So, that will be 0.85 F prime C A times BW plus C2 will be 0.85 F prime C, that will be BE, or B sub F, minus B sub W times H, or TS, is equal to AS FY. So, coming from this, we can compute for A. So, arrange natin. So, that will be 0.85 F prime C ABW is equal to AS FY minus 0.85 F prime C BE minus BW times H. So, dividing both sides of the equation by 0.85 F prime CBW, so we could arrive to a value of A equivalent to 0
AS. This will be AS ASFY minus 0.85 F prime C BE minus BW times H divided by 0.85 F prime C BW. So that will be the value of the theoretical value of A coming from the diagram. These diagrams as well, pwede natin i-determine si nominal moment capacity. So, this is Mn1 ulit for Mn. Then, for Mn1, then Mn2. So, meron tayong C1, ito, T1, then this will be C2, and this will be T2. So, we just need to determine the moment arm for each stress diagram. So, for this stress diagram, so that will be, so, kung yung distance from the compression to this one, or to the tension reinforcement, or centroid of the tension reinforcement is D. So, ibig sabihin, ang moment arm for the first diagram will be D minus A over 2. Then, for the second diagram, for the second nominal moment, the moment arm will be equivalent to D minus H over 2 kasi dito lang siya. So, divided by 2 lang yun. So, that means we're going to get the first nominal moment. So, lagi ulit tayo on the compression. So, that will be 0.85 F prime of C A times BW times, that will be D minus A over 2. So, yan ngayon yung nominal moment capacity of the beam, or the first nominal moment capacity. Then, for the second nominal moment capacity, that will be Mn2 is equal to 0.85 F prime C. So, that will be BE minus BW times H times the moment arm D minus H over 2. So, yan yung second nominal moment capacity. So, to get the nominal moment capacity of the beam, i-add lang natin yung dalawang nominal moment capacities of the two diagrams, or of the diagrams. So, then to get the ultimate moment capacity, we will just get phi mn. So, that will be for the second method to be used for the analysis of A-beams. So, yung last method natin for the analysis of AT beam is more on the statics, or more on statics. So, kung given tayo or binigyan tayo ng analysis, or binigyan tayo ng beam na proven to be analyzed as AT beam, so ang gagawin natin is kailangan natin nung centroid nung compression area niya. So, ibig sabihin, ang kukunin natin kasing centroid is coming from the top papunta dito. So, papunta dun sa centroid niya. Let's say that is Y bar. So, kaya more on statics part to kasi we will be using the Varignon's theorem. So, Varignon's theorem will be equivalent to AY bar plus, or AY bar is equal to, that will be, is equal to A1 times Y1 plus A2 times Y2. Let's say, hahatiin natin tong beam na to into two parts. So, let's say, hatiin natin dito. Dito din. So, hatiin natin na ganyan. This is area 1. This is area number 2. So, ibig sabihin, so, kung ito yung thickness ng slab, so, ibig sabihin, that will be equivalent to AY bar is equal to yung area 1 natin will constitute BF or BE times thickness of slab, tapos ang Y1 niya or ang centroid ng figure na yun or ng area na yun is TS over 2 papunta sa taas, plus area 2 will be syempre B sub W na yun times that will be A minus the thickness of the slab. So, yun yung area niya. So, ibig sabihin, ang area din nun or ang centroid nun nung second area will be a value A minus TS over 2 plus T sub S. So, mapapansin natin, if we simplify this one, this will be AY bar is equal to, that is BF TS squared over 2 plus B sub W times A minus TS. Tapos, ito will be A over 2, kasi ito A over 2 lang. So, negative TS over 2 plus TS, that will be positive. So, that is positive TS. So, that will be over 2. So, ngayon, para makuha natin si Y bar, so, that will be equal to BF TS squared over 2 plus BW times A minus TS times A plus TS over 2. So, divided by the total area. So, yung total area natin is BF times TS plus BW times A minus T sub S. So, yan ngayon yung pangkuha natin ng Y bar natin. Pag nakuha na natin yung Y bar natin, syempre, may given to na or hahanapin natin kasi din yung effective depth which is D. So, ang tendency kaya natin kinuha yung Y bar galing dun sa taas ng figure is para kapag kukuha na tayo ng nominal moment capacity ng beam, so, pwede natin kunin yung nominal. So, yung nominal, it's either coming from the compression side or the tension side. Pero sa case natin, mas madali kung sa tension side natin siya kukunin. Kasi magiging ASFY lang yan kapag yielding yung steel. Or FS kapag hindi yielding. So, ito lang naman yung mapapalitan. So, this will be FS. Para hindi masyadong madugo yung equation natin. Then, ang magiging moment arm will be D minus Y bar. So, yan na ngayon yung magiging nominal moment capacity of the beam coming from this method. Then, automatically, makukuha na natin yung ultimate moment capacity kapag minultiply natin yung nominal moment capacity dun sa reduction factor. Sa part for the balance steel ratio ng T-beams. So, dun muna tayo sa condition kung saan yung A natin is lesser than or equal to T sub S. Meaning, kailangan pa rin natin ng analysis ng rectangular beam. So, ibig sabihin, ang balance steel ratio pa rin nito will be the same
as dun sa pagkuha natin ng balance steel ratio for a rectangular beam. So, bali parang ang lalabas na yung raw balance is yung kagaya ng dinederive natin for a rectangular beam. Parang yung sa singly reinforced beam lang. So, that is just 0.85 F prime C. So, that will be beta 1 C balance divided by FYD. Kasi dyan galing yun. Then, si C balance, makukuha lang natin yan from the strain diagram. Ito. So, strain diagram lang siya. Derived strain diagram. So, let's say this is 0.003. Ito yung C balance. Tapos, ito yung D. So, ito, this is Fy over Es or siya yung epsilon Y. So, or strain Y. So, meaning that is C balance over D. So, kung kukunin natin yung ratio niyan, pwede kasi natin tong ibaba. So, kung ganyan yan, pwede kasi nating ibaba si 0.003 papunta rito. So, meron kang 0.003 dito. So, ibig sabihin, pag nag-ratio and proportion tayo, kung ito si C balance, let's say this is C balance. So, that means that will be 0.003. So, that will be 0.003 plus E sub Y. So, ang C balance natin manggagaling sa 0.003 over 0.003 plus E sub Y D. Yun ngayon yung magiging condition for the balance steel ratio for A's or yung actual value ng A lesser than or equal to T sub S. The condition naman na na-prove natin that kailangan natin siyang i-analyze as a T-beam. So, ibig sabihin, yung actual value ng A is greater than the thickness of slab or H. So, ibig sabihin, kailangan din natin kunin yung balance steel ratio coming from a T-beam as well. So, pwede nating gamitin yung dalawang method. Pwede nating kunin yung raw balance from equilibrium equation. Then, pwede din natin kunin coming from method 2. So, para makuha natin yun, syempre, dadaan ka pa rin sa part kanina na kukunin mo yung value ni C balance coming from the strain, which is, ang mapapalabas natin yung 0.003 over 0.003 plus E sub Y D. Dito natin makukuha si C balance. Then, on the part of the raw balance ngayon, ang mangyayari is, syempre, magkakaroon ka ng dalawang. So, kung ito si H, magkakaroon ka ngayon ng dalawang compression for the equilibrium equation. Let's say, meron tong steel dito sa baba, which is A, S. So, that will be 0 point or start tayo sa equilibrium equation. So, since dalawa yun, pwede ka kasing hati natin to dito. So, that will be, ito si C1, ito si C2, tapos ito yung T. So, that will be C1 plus C2 is equal to T. So, coming from this equation, we have, so for C1, that is 0.85 F prime C. So, ang gamit natin, yung C1 natin is H times BF, yung area ng concrete niya. So, that is H times B sub F plus, that will be 0.85 F prime C. So, yung C2 natin will be A value, A balance, minus the thickness of slab or H times BW is equal now to AS balance FY. Then, next will be yung AS balance natin ngayon dyan. Meron niyang value na B or rho balance B D. So, ang kukunin nating B, since umabot na din pababa yung C balance natin dyan, ang B natin dyan will be BW. So, that will be BW. So, that is B sub W. That will be D. So, that means yung A balance natin same. So, A balance is equal to beta 1 C balance. So, that will just be 0.85. That is F prime C. Then, that is BF times H plus 0.85 F prime C. That is beta 1 C balance minus H is H times BW is equal to rho balance BWD FY. Then, kunin natin yung rho balance. So, ang magiging equation natin would be rho balance is equal to, that is, labas natin si 0.85 F prime C. So, 0.85 F prime C. So, that will be BF times H plus, that is BW times beta 1 C balance minus H divided by BWD FY. So, yan ngayon yung value ng rho balance natin. So, isang method lang to get the value of the rho balance. Yung sunod nating method for the computation ng balance steel ratio kapag na-prove natin na T-beam analysis siya is nakuha lang natin or na-derive lang natin from or madi-derive natin from method 2. So, hinati natin siya. So, meron kang ASW for the web. Tapos, meron kang ASF for the flange. So, ang mangyayari, parang sabi kasi, the raw balance of a T-beam is equal to a raw balance bar plus raw no flange. So, that will just be yung raw balance bar. Kung mapapansin nyo kasi, if raw balance bar to, siya daw yung, so yung raw balance bar, siya yung balance ratio for singly. Kasi kung mapapansin nyo, yung first diagram na to is just kagaya lang ng singly reinforced.
siya. So, that means, kung i-derive natin siya, so, raw balance bar, so, that is raw balance bar. So, kung gagamitin natin yung yung first diagram, ito. So, that means that will be from C is equal to T, or C1 is equal to T1. That will just be BW, or 0.85 F prime C. So, that will be A balance BW is equal to AS W balance times FY. Whereas yung ASW balance natin dyan will correspond to a value of raw balance BWD. Tapos yung A balance natin will correspond to beta 1 C balance. So, ibig sabihin, meron na ulit tayong equation of, sinang natin ito. This is W. So, that will be an equation of 0.85 F prime C beta 1 C balance. So, yung BW kasi magka-cancel yan eh. So, mapapansin natin magka-cancel out. So, that will be equivalent to yung raw balance na tinutukoy natin dito is raw balance bar, which corresponds to a singly reinforced beam. Raw balance bar DFY. So, kasi etong, kung mapapansin nyo, itong diagram na to, para siyang singly reinforced na diagram. So, singly reinforced rectangular beam na diagram. So, that will be raw balance now is equal to 0.85 F prime C beta 1 C balance divided by FYD. Siya ngayon yung raw balance bar. Ngayon, yung raw F na tinutukoy dito is for the flange. So, meaning, ang gagamitin nating diagram is itong diagram na to. So, that will be, so, para malaman natin yung raw F na yun, so, that is just C2 is equal to T2. So, that will be 0.85 F prime C. So, that is H times BE minus BW is equal to ASF times FY. Remember, ASF is equal to rho of F times BD. Pero ano yung B na gagamitin? Ang gagamitin nating B is BW. Kasi remember, yung sa balance condition, tumatama si C balance dito na sa BW, hindi dito sa itaas. So, ibig sabihin, that is just BW. So, that will be 0.85 F prime C BE minus BW times H is equal to rho F BW DFY. So, creating a rho W equation of, or rho F equation of, so rho F is now equivalent to 0.85 F prime C That is H times BE minus BW divided by BWD FY. Yan na ngayon yung raw F natin. Then, we just add the result of these two to get the value of the raw balance. So, this method and the other method I have introduced will yield the same answer. So, that will be for the concept of T-beams. So, that will be all for the concept on the analysis of T-beams. So don't forget to subscribe on my channel, Butch TV. So kindly like, share, and subscribe. So huwag nyo rin kakalimutan mag-subscribe on Engineer Nyoros YouTube channel. So Nyoroskis Engineering Online. And dun sa iba pang professors na gumagawa ng YouTube videos lectures for lectures on other subjects. So thank you for watching.